Welcome to Atomicast. Episode 1: The History of Atomic Theory.
We good?
Yeah.
Yo, what's good? I'm J-Beams, and welcome to Atomicast, the podcast with hot topics and even hotter questions. Today we have some special guests, a group of atomic theorists throughout history. Welcome. First, we will start with Democritus. Tell us a little bit about yourself.
Hello everyone, I come from around 400 BC. I created the first known atomic theory when I realized that everything is made up of atoms. I come from Greece and was born around 460 BCE.
Explain a little bit about this theory for our listeners.
Of course, the premise behind my theory is that there's an infinite number of atoms and infinite kinds of atoms that differ in size and shape. These atoms are physically indivisible, which means they are indicative and cannot be broken down. I call these infinitely small pieces of matter atomos.
So, how did you come up with this theory?
Well, I knew that if you took a stone and cut it in half, each half would have the same properties as the original stone. And if I continued to cut the stone into smaller and smaller pieces, at some point I would reach a piece so tiny that it could no longer be divided, which is how I came with the atomos.
Thanks for your time, my man. Next up, we have John Dalton.
Hey, Mr. Dolan, thanks for coming, bud. I was wondering how your ideas contributed to the development of atomic theory.
Well, soybeans, when I was born in 1776, the current atomic theory of matter was the one by Democritus. I enjoyed this theory and wanted to explore it. I believe that all elements were made of their own atoms. I too believe that atoms were indivisible, and I overall tried to better Democritus' theory.
That's very interesting. And how did you do that, and what experience did you use?
Well, soybeans, I experimented with gases and did experiments
wow.
involving evaporation. Yeah, I found that certain gases could only be combined in certain proportions and circumstances. This led me to hypothesize that things combined at the atomic level in fixed ratios, thus leading me to realize that atoms could combine.
Nice. Okay. Thanks for coming.
Yeah.
Next up, we have J.J. Thompson.
Hi, thank you for having me. I was born on December 18, 1856 in Cheetham Hill, Manchester, England. I attended Trinity College at Cambridge, where I became the head of the Cavendish Laboratory. This is where I discovered cathode rays, which led me to one of my accomplishments of creating more precise equipment to study these rays. Another accomplishment that I had was the discovery of electrons. I found that matter was made up of small particles that I originally called corpuscles, but later the name got changed to electrons. This was one of my most important accomplishments as it led me to my version of the atomic theory.
So how else did you contribute? What experiments did you do to get this stuff?
I discovered that atoms are complex objects made up of negative and positive pieces, and that the negatively charged electrons within the atom are much smaller compared to the atom as a whole. This is what
Alright, we're good. Keep going.
This is what led me to come up with the name plum pudding model. This is because the atoms have a similar structure to plum pudding. The tiny negative electrons are embedded in a positively charged substance.
Very interesting. I don't think I've ever had plum pudding, but sounds cool. Was your contribution acknowledged?
Yes, in 1906, I was awarded the Nobel Prize in Physics through the experimental investigation, which led me to the creation of electricity through the movement of gases.
Thank you.
Next up, we have Ernest Rutherford.
Okay. Welcome, Ernest. Tell us a little bit about yourself.
Well, soybeans, thank you for having me. I was born in 1871 to a large family. I was one of 7 sons, and I also had 5 sisters.
Wow, that sounds like you had really quite a big family there, bud.
Yeah.
What research did you do that helped advance atomic theory?
Well, soybeans, I worked with my partners Hans Geiger and Ernest Marsden to find that there was a small center to an atom. This center we called the nucleus.
That is a very big discovery. How did you come to this conclusion that there was a center that you called the nucleus?
Of course, me and my colleagues conducted an experiment that was called the gold foil experiment. We shot alpha particles at a sheet covered in zinc sulfide, which would emit a flash of light when it was hit with an alpha particle. However, I knew that alpha particles had lots of mass and speed, and I believed they would break through this in a thin metal foil. After we shot the particle through the thin sheet of gold, we found that the molecules were scattered more than 90 degrees. This led us to the conclusion that there was a small area where most of the mass was in the center of the atom.
That is super lit, my dog.
Yeah, it was really cool.
Well, thanks for coming on the pod.
Yeah.
Yeah, see ya.
Thanks, yeah.
Welcome to the podcast, Robert Millikan.
Go.
So tell us a little bit about yourself, Mr. Millikan.
Sure, I was born in 1868 in Illinois and always kind of wanted to be a scientist. I became fascinated by electrons in the early 1900s and devised an experiment which I could use to measure their charge. I ran a current through water to vaporize it and then measured the charge of the mist. And for that, I discovered that the electron is a negative particle.
Fascinating. Were you acknowledged for this discovery?
Yeah, I won the Nobel Prize in 1923 and was also offered many jobs at a laboratory, and I took one in San Marino, where I live.
Wow, thank you for coming, Mr. Millikan.
Of course, anytime.
Next up, we have Niels Bohr.
Welcome, Niels. Can you tell me a little bit about your backstory?
I'm live.
Hi, thank you for having me. I was born on October 7, 1885 in Copenhagen, Denmark. For most of my life, I've been interested in physics, and that is what led me to become a physicist. I studied physics for both my undergraduate and graduate, in which I earned my doctorate in 1911 from Copenhagen University.
Very interesting. Can you tell me a little bit about your accomplishments?
Sure, one of my major discoveries was the quantum concept, which restricts the energy of a system. For this discovery, I was given the Nobel Peace Prize in 1992.
Wow, that just really astounds me that you got that beautiful, just eccentric prize. It's not the right word. So what did you contribute to atomic theory?
The atomic model that I created is a modification of the Rutherford model, but it is called the Bohr atomic model. The idea of it is that it has an atom with a positively charged nucleus surrounded by negatively charged electrons. In this model, the electrons have defined circular orbits in which they orbit around the small positively charged nucleus. It is commonly referred to as the planetary model because the orbits are similar to the way that the planets orbit the sun.
That's just the beauty of a theory. Thanks for your time.
Up next on the podcast, we have Edwin Schrodinger.
Welcome, Edwin.
Thanks for having me, dog.
So what's your backstory? Where do you come from?
I am from Austria and was born in Erdenberg in 1887. The majority of my education came from the University of Vienna, and I won the Nobel Prize in Physics in 1933 for my work when I created the electron cloud model and the wave equation, which I'll tell you about later.
So when did your career start in science? Like, when did you start doing experiments?
Well, as a child, I read a lot of science books in English, which initially sparked my interest in science. And after I went to the University of Vienna, where I specifically got interested in physics, and I had a brief break in my studies when I had to serve in World War I. Then I came back and went to the University of Zurich for the next 6 years, where I completed a lot of my research and findings.
World War I was a tough war, but
Yeah.
congratulations for doing that. What is this electron cloud model you were talking about earlier?
Well, as I said, I won the Nobel Prize for this electron cloud model, which is pretty dope. And it's kind of a more modern version of the Bohr model. It deals with the fact that we do not know the exact location of electrons, like Bohr thought, and it instead shows only the general area of these electrons. And theoretically, scientists can predict where a particle might be if they were to create a wave equation, which no one created an equation before I did. And I created it so I would be able to figure out the probability of a particle being at a particular spot at a particular time. And it is now known as the Schrödinger equation.
Very interesting. Thank you so much for your time and sharing your knowledge with all of our listeners.
Of course, J2 Beans.
Our last guest on the podcast is James Chadwick.
Well, welcome to the podcast, Mr. Chadwick. So how you doing?
I'm doing well. How are you?
I'm pretty good. So today there's been a lot of discussion about the contributions of various scientists to atomic theory. And where do you fit in this?
I suppose I fit in two places. First was my groundbreaking work with the discovery of the neutron. That was my biggest discovery, and likely why I'm here. And the other thing I did was lead the British team during the Manhattan Project to develop the atomic bomb.
Nice, that's very interesting. And the neutrons, how did you go about discovering them?
Well, I was playing around with alpha radiation, which is basically a helium nucleus, 2 protons, 2 neutrons. Of course, I didn't know that at the time. And I was making it hit beryllium, and it was shooting off particles and run into other ones. And in order to do that, they had to be neutral, which meant that it couldn't be any of the particles that we knew about then. So, new particle.
Nice. Well, thank you for your time. Thanks for coming to the cast.
Of course.
Thank you to all our guests on today's podcast.